Yeah. I don't think that. No, by the way, just for the record, I am live right now, but I don't think that there's ever a good time to get it. Presumably, you would hope not to. And for the vaccines that are coming out to hopefully take care of that. Like, I'll give you an example. I have no idea. When you guys were kids, did you get chickenpox, or was there a chickenpox vaccine?
Well, I think I don't remember, but I think it might have been a mandatory vaccine that your parents had to give you.
Okay.
It's like, I know some vaccines they give you as a choice.
I want you to imagine this. When I was a kid, it was like a rite of passage to get chickenpox. They wanted you to get chickenpox. Basically, like, you got chickenpox and it's just like, oh, you talk to like your older siblings or cousins, they're like, oh, I remember when I had chickenpox and blah, 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 blah. Parents would purposefully find out, oh, this kid has chickenpox. We're going to have what they call a chickenpox party. This is a real thing, where like a bunch of kids will go together with that one kid and like play with that one kid who has chickenpox so they could also get chickenpox, so they can get it over with. It is, but the idea is you had to get it when you were a kid, because if you got it when you were an adult, it could potentially be devastating. It was much safer to get it when you were a kid. No, that's true. Chickenpox is very common, very, very common, to the point. But again, today, my kid got a chickenpox vaccine. He will never experience getting those things growing all over his body and then picking off the scabs. I know. How sad is that? He won't experience it. Whatever. But no, it's like I remember very distinctly when I had chickenpox, I came downstairs and my mom's like, oh, yep, you're not going to school. And it was like very common. It was very much like, well, we're not panicked because we know what this is. Like, oh, snap. Like, I don't remember. My dad remembers when he grew up having a fear of polio. Polio just wrecks your nervous system. You lose the ability to function in certain ways and things of that nature. But now there's a vaccine for that. And well, I'm sorry. Well, there is a vaccine for that, but they basically eradicated it. It's gone from the United States, at least. Anyhow, fun stuff. But FDR had polio, right? Franklin Delano Roosevelt had polio. Yeah, he lost the ability to walk in certain points. They faked him walking. Yeah.
And when he used to speak like to the public, they used to like hold him up, but they had to make sure the stand is always there so no one would notice.
To cover his legs. Yeah. Then the other thing was, like, he used to swim in the White House pool as therapy. But then that water, because it was back in the day before like filtration, that water became very like polio stricken. So they had to like drain the pool, but they couldn't really just get rid of the pool. So you know what they did? They covered it up and they built the White House press room over it. I'm not even kidding. Where they ask like the president all the questions. No. They drained it. Believe me. Yeah, the shape of the room is the size of the swimming pool. Anyway, let's talk about Cali scores. So, Cali scores is an official designation for each individual county in New Jersey. I believe it's in the United States as well, but I'm talking about New Jersey specifically. Now, a Cali score is based on 1, 2, 3, 4. Have you seen the maps where New Jersey has their counties listed as green, yellow, orange, or red? You not seeing those maps? Hey. There we go. Yeah, well, right now, I should try to bring up one of these maps. You've probably seen them before. But yeah, New Jersey has this Cali map designation. Hold on. COVID weekly report, New Jersey. I can easily find this. It's called an activity report. There it is. This one is for the week of November 14th. This one is for the week of November 14th. Now, obviously, there's already one out for the week of November 28th, and we're currently waiting for the newest one to come out. Now, here's the thing. It goes low, moderate, high, very high. Currently, Ocean County is in the high range. Currently, according to the November 28th report, the entire state is in the is in the high range. They're all orange. Now you can see right here when we initially shut down, we shut down around March 14th, around that time. And then boom, it went red soon thereafter. That was the high category. It's the very high, the highest you can get. And then eventually it back down. And then we opened the schools back up. And then it went yellow. And then we're back in orange. Here's the thing. Maybe, I don't know. If we go red, the schools go virtual. I'm just saying. Say again? I don't know. No, for as long as we're red. Yes. For as long as we're in the red category, we have to go virtual. And then after that, decisions can be made. As long as we're orange, the school districts in the county have the option to go fully virtual, but they don't have to. Now, what designates a county going orange or red is actually very, very interesting. It's based on 3 particular categories. It's based on cases per 100,000 people. That's category 1. It's based on COVID-like illness rate, which basically means if you go to the doctor but you don't have COVID, but you have COVID-like symptoms, they report that for the CLI rate. It's really up to a doctor's opinion, I guess, at that point. And then the third category is positivity rate, meaning we all go in, we all get tested. How many tested positive? The percent, that is the positivity rate. Now, each category is based on a score of 1, 2, 3, or 4. And they average them together. And whatever whole number it rounds to, that's our Cali score. So currently, right now, now mind you, this is the November 14th report. Let's see if I can't change it to the change it to 47. Will it give me the, yep, there's the 21st. Let's change it to an 8. There's the 28th. I don't think that they have the newest one, but let me just see if they have it regardless. Nope, error does not exist. Okay, so here's the latest numbers as of that report. Now you can see right here, we are Central East. Here is our case rate per 100,000 people. Here is our percent CLI, and here is our percent positivity. What has happened in the past week in New Jersey in terms of the number of cases? It went up a lot. We broke records multiple days in a row. 5,000, 6,000 cases in a day. That percent positivity rate for the entire state is over 10% right now. It's over getting close to 11% right now. Now, what that means is that this percent positivity rate, where's my marker? That percent positivity rate, when the new report comes out, will most likely be ranked a 3. That's not us. Will most likely be ranked a 3. Currently, our case rate is ranked a 4. Our percent CLI right now is ranked a 3. So I'm saying that when the new report comes out, our Cali score will be an average of 4, 3, and 3, which is 3.3 repeating, which rounds down. We will still be orange. We will still be 3 out of 4 when the new report comes out. Well, Mr. Markey, how do you get up to a 4? Well, either you have to have all of these being 4, or you have to have some combination of 4, 4, 3. Here's the thing. In order for the percent positivity rate to be a 4, you have to have over 20%. Do you know what brings this number down? Percent positivity? Have you guys driven past urgent care or something like that? Or not urgent care. What's that place in front of a Walmart? Atlantic Care? Have you seen the lines? You see, yeah, you know what I'm talking about. There are lines of people getting tested. Oh, I'm so panicked. I'm so panicked that I'm going to get COVID. I have to get tested. I have to get tested. If you have 100 people getting tested when they don't really have to get tested, that's going to bring that percent down. This number is artificially deflated. It's deflated because people are panicking. This number, percent CLI, that is contingent upon the doctor assuming that, oh, you do have COVID-like symptoms, but you don't have COVID, so I'm going to report that number. But it's their opinion. It is their opinion. It's a very subjective standard. It's a game. It's a giant game of let's figure out the Cali score. And then they have all these numbers down here to kind of figure that out. If you have a case rate that's over 25, you're in the value of 4. You have to have over a 13% CLI to have a value of 4. Right now we have a value of 3. You have to have over a 20% positivity rate. This report had us at a 2. We're going to be at a 3. I don't think we're going to get to a 4. Your best case scenario is one of two things for going fully virtual. Either you have people who actually have it or who actually fear that they have it going and getting tested rather than people who are like, oh, I'm going to get tested again for the 100th time this week. Or you have doctors actually reporting on people having COVID-like illness. I don't know. It's going to be a fun time. Cali scores are a fun thing. I learned all about them this past week. Just kind of paying attention to this thing. But think of it this way. After this upcoming week, we will have a Cali score of 3.3. What number rounds up to 4? What's the minimum number that rounds up to 4? 3.5. So you're telling me we're like 0.2 away from shutting down? Yeah. But getting that extra 0.2 or getting up to 3.6 in order to round up, you're not going to get it that fast. You're not. It's just the way that the system works. Anyway, that's fun. Oh, goodness gracious. Okay, here's what I want to do. To kind of start this lesson out today. Oh, I got comments in the chat. Yeah. To start this out today, I'm going to give you this worksheet. And I want to talk about some of the problems on this worksheet. Y'all don't need your Chromebooks. Stupid Chromebooks. Now, for those of you in the chat, I am going to send in a PDF for you momentarily. I just got to get these passed out here. Oh no, paper. That was him. There's 2 in there. Now, I would like to go over various aspects of this worksheet with you to continue what we've been doing with probability. Let me get this right here. No, I'm good. I'm going to save this PDF, but only page 11. I'm going to save that to the desktop. And I'm going to put this in the classroom. Now, if you guys take a look at number 1, just number 1 in that particular worksheet, you're going to see something very timely. People talking about holiday meals. Just fantastic. Now, holiday meals. A survey of families revealed that 58% of all families eat turkey on holiday, or at holiday meals, I should say. There we go. Posted. 44% eat ham, and 16% have both turkey and ham to eat at holiday meals. Then they ask a bunch of questions beyond that. Now, I'm going to ignore the questions temporarily. Just so you guys know, in the chat, I believe I just posted the PDF for you. You can take a look at what we're looking at. Before we actually get to the questions, I want to map out what the heck is going on with number 1 in terms of turkey and ham. So what I would like you to do, flip that worksheet over, and I want you to draw the following image. If I can actually get this thing loaded here. Here we go. I want you to draw the following image. You okay? Where'd the other one go? Yeah. There were 2. I gave you 2 and 2. Oh. You guys are wrecking me right now. Anyway, I want you to draw the following image. I'll draw it like this. Here we go. I want you to draw that following image right there. Move that up in the corner so people can see that a little bit better. There we go. Now, you guys are somewhat familiar with Venn diagrams. I don't know if you extensively were taught Venn diagrams back in the day, but you're somewhat familiar, I guess, with the concept of them. Venn diagrams are showing like, okay, here's two particular categories, what they have in common. We write in the middle, okay, fancy, wonderful, all that wonderful stuff that we have going on here. I want to draw this one. I'll draw this a little bit darker. Draw this a little bit darker. I'm going to draw the exact same thing. I'm just going to draw a little darker right here. There we go. Now, this category, you can write the word turkey. And this category, we can write the word ham. Zooming in, zooming in, zooming in. This Thanksgiving, my wife got a boneless butterball turkey. It was the juiciest turkey I have ever eaten in my life. I have so been used to nothing but dry turkey forever. Question: is it considered a faux pas to eat turkey whilst dipping it in mashed potatoes? What a response. Say again? What does faux pas mean? Like a faux pas is like a not socially accepted action. Like, for example, if I were to walk in this room without shoes or socks, that would be considered a faux pas. I'm just saying, like, you eat a piece of turkey, dip it in some mashed potatoes. Of course. Yeah, but there are some people that are like, no, I don't mix the food on my plate. You guys are going to be using that word for like the next 2 weeks. You're like, that's a faux pas. Anyway, now, in regards to this particular worksheet that we're working on, there are certain percentages that we have to play with. Now, yes, they gave you 58% of all families eat turkey, 44% eat ham, but I'm more interested in the 16% that eat both. 16% eat both. Now, if you notice, I put it in as a 0.16. I like writing percentages as decimals just for the sake of argument. But I put that 0.16 in the middle because 16% are in both categories. Fantastic. Question: what do I write here? I'm going to leave my pen pointing at that spot for a moment. What number do I put there? Ooh, I can't put 58. Because think of it this way. The paper says 58% of families eat turkey, correct? Yeah. Which means, and I want to be very clear with how I'm kind of circling this, 58% of all families eat turkey, which means look at the circle that I'm doing. This entire circle should add up to 58%. This entire circle should add up to 58%. 0.42. In this portion to the left, I'm putting a 0.42 because now the turkey circle, which overlaps the ham circle, adds up to 58%. Sorry, I'm just looking at the comments now. Sorry. I was a little late getting to the comments in the chat, and she was still talking about Thanksgiving dinner. So knowing that piece of information about the turkey, what am I going to put here? What am I going to put in that spot for ham? 0.28. Because what did it say? 44%. 44% eat ham. 0.28 go here. Now, what does this all mean? What do these numbers mean exactly? I want to be very clear with how I word this. 16% eat both. Now watch me as I point to these. 58% eat turkey. Hey. Chapa! There he is. But now, 42%, I'll get you the worksheet in a moment. 42%, listen to my words, only eat turkey. 58% eat turkey, but 42% only eat turkey. Meaning, 42% eat turkey, but no ham. 28% eat ham, but no turkey. 16% eat both. It's this weird kind of Venn diagram relationship where it's like, yeah, I mean, back in the day when I was growing up and we had like 50 people when we were allowed to at a Thanksgiving dinner, yeah, my family was one of the 16% that ate both. We were one of the 58% that ate turkey. Now, mind you, that 58% is made up of families that only have turkey and families that have both turkey and ham. It's a weird kind of connection that they have going on there, but we need to be able to recognize how to structure this Venn diagram before we get to any of the questions. Question: how many families do not eat turkey or ham? What percent of families eat neither? It's 14. Yeah, it's 14%. Now, the way that you can kind of figure that out is the general idea that these percentages should add up to a certain amount. These percentages by themselves add up to 86%. That's why I put a box around it. 0.14 eat neither. 0.14 eat neither. It's a weird way of putting it. It's a weird way of thinking about it. But we have to be able to structure Venn diagrams in such a way in order to eventually answer all these questions. Now, I could say something along these lines. As I said, the percent of those who eat turkey, they gave it to us right in the problem, was 58%. The percent of those that ate ham, they gave it to us at the beginning of the problem. What was it, 44? Yeah. No, it was 44, right? Cool. The percent that eat both, they gave it to us as 16. Those are the only pieces of information that they gave us. But now we can actually structure a Venn diagram and answer said questions in the way that they want us to. It's so weird. I don't believe I wrote this. I think I may have written this down into our notes. It's been quite a while since I've thought about it. Did I give you any information in the past about whether or not events were mutually exclusive? Okay. Mutually exclusive is a phrase that you possibly would remember, given the notes that I gave about them. Again, it's been quite some time. I can't recall if we wrote that down. Mutually exclusive events, if events were considered to be mutually exclusive, would mean that the probability of both of those events happening would be 0. And again, I'll write this down into our official notes in a little bit. If events were to be considered mutually exclusive from one another, it would mean that these two events have no overlap between them whatsoever. They would be basically, this middle portion would be barren and empty. Now, I'm going to leave this up here just as a reference. but flip your paper back over to the questions. I'm going to leave this up here as a reference. There they are. But now let's actually look at the questions. First question. What is the probability that a family selected at random had neither turkey nor ham at their holiday meal? Got it. Which is what? 14%. Say again? Yeah. There's some that don't. It's mainly tradition. Name another time during the year besides major holidays that you regularly eat turkey. I said besides major holidays.
Oh my God, that's literally a holiday.
Besides major holidays. It technically is.
It's like a national holiday.
It's more than just a national holiday. Yeah, it's a worldwide holiday. I don't think you eat turkey on Chris Columbus Day. Okay. Anyway, part B. What is the probability that a family selected at random had only ham without having turkey at their holiday meal? 28%. And the thing is, you don't have to think about it too much because you put in the work in the Venn diagram. These problems can most likely be answered by creating that Venn diagram. And by having that done before you read any of the questions, you have all the answers already. You just have to recognize which one's which. Part C. What is the probability that a randomly selected family, having had turkey, had ham at their holiday meal? Now, this one's a little trickier. This one's a little trickier for a couple reasons. This one's a little trickier for a couple of darn reasons. Number one, the wording. What is the probability that a randomly selected family having turkey had ham at their holiday meal? I will tell you that the actual answer is not written on the board right now. I will tell you that the actual value to part C is not written on the board right now. What do we need to know? What do we need to know? Well, I'm going to move this up just a little tad right here. What do we need to know? Now, what I'm about to write down, I am going to be putting into our notes in a little bit. I am going to be writing that into our notes in a little bit. So don't worry too much about like, what? Well, technically, we have written a similar version of this formula down already. We wrote down this. We wrote down that already, that weird A and B. Okay, and implies multiplication. I would have to multiply those two events together. Do you guys remember what that symbol, that vertical line symbol meant, what that word was? Given, it's the word given, the probability of B given A. B given A. The probability that event B will happen given that event A has already occurred. Now, the reason why this relates to the problem that we are working on for part C, the reason why that relates to part C, what is the probability that a randomly selected family having turkey had ham at their holiday meal? What that question is actually asking is this. That's what it's actually asking right there. Here's the thing that you got to know. The hardest part about any of this probability stuff that we are dealing with The hardest part is going to be the wording of the question. The wording of the question. I'm going to read that question again, just exactly the way that they have it here, and then I'm going to try and reword it a little bit. The question is, what is the probability that a randomly selected family having turkey, given that they had turkey, given that this family is already eating turkey, what is the probability that they had ham, given that they have turkey? That's what this question is really saying right here. It's a weird kind of what they call conditional probability. And I'm going to have you guys write some of this stuff down in your notes a little bit. But that's what we got to do. That's exactly what we got to do. So here's what I'm actually going to divide. Look at the fraction that I just put up there. Now, where did these numbers come from? Hey, what is the probability, according to the Venn diagram that you guys wrote down, what is the probability that they had turkey and ham? 16%. There's the 0.16. And what is the probability? Now, keep in mind, just listen to the vagueness of the question. Not the vagueness of the question, whatever. What is the probability that a family had turkey? Say again? 58, which includes those two numbers. There's the 58 on the bottom. That's where those numbers came from. It's a weird kind of thing that we got to do here. Approximately 0.276. That's where that answer would be. Now, just for the record, part D, are having turkey and having ham disjoint. Here's what I want you to do. For part D, under the word disjoint. Under the word disjoint. Don't cross out disjoint, but I want you to write the words mutually exclusive. Mutually exclusive. They mean exactly the same thing. Just a different phrasing. Disjoint and mutually exclusive. Think about it. What happens if your shoulder comes out of its joint? What does that kind of look like? For you guys to understand like anatomy. Right? Now think about it, like how does the shoulder socket actually look? The shoulder socket is like, the top of the shoulder is like, just kind of like a ball, whatever. And then the shoulder socket, like it just goes into the socket like that, right? Yeah. But then if you dislocate your shoulder, it becomes disjoint. It becomes separated. Oh no, you need to pop it back in. Disjoint is like a Venn diagram that has been separated from each other. The two circles have been pulled apart. Disjoint is mutually exclusive. Disjoint means they have nothing in common. Part D, are having turkey and having ham disjoint events? Yes or no? Are they mutually exclusive? Is the probability of turkey and ham equal to 0? Shaking your head, no. It's no. It says, explain. Well, the answer is no, because the probability of turkey and ham is equal to 16%. It's not 0. That's all that you have to answer for that problem. Yes. Good question. That 44% is a very specific probability of having turkey but no ham, or only turkey. So, oh, my bad. Sorry, I was thinking turkey. I apologize. You see these letters? Okay. Ham is that B. Turkey is that A. We're dividing by the probability of turkey. 44% represented ham. So that's why we got to divide by 0.58. No. It has nothing to do with that. It has nothing to do with the size of the number at all. It has everything to do with these phrases, these events right here, and the order that they occur. In fact, when you are doing this particular, what we call conditional probability, you always divide by the given event. The given event, meaning given turkey. You always divide by whatever that second thing is. We'll get into it. So, what I'm going to ask, we're going to come back to this. In fact, we're actually going to come back to this for a couple of class periods. I'm going to ask if you do not already have them out, I'm going to need those notebooks out and open. From the what?
I said it never fails.
I know, right? Now, I've talked about some of these things in the past few weeks, but I want to reiterate some of these phrases and some of this notation so that we are all on the same page. That goes there, and that goes there. There we go. So this is called conditional, if I could spell it today, probability. Today is actually the 8th. There we go. Who in the what? Oh, he just wanted to say it. Did you know that there actually was a St. Nicholas that would deliver presents to underprivileged children in his village back in the 1800s? And that it was mainly Coca-Cola that made him have a red suit? Yeah. Anyway, conditional probability. Conditional probability comes down to, well, probability given a certain condition. It's conditional because something has to happen before in order for the event that you're looking for to happen. I've talked about this, but I want to make sure that I emphasize these points. The probability, this is how you would read this. You would literally read this as the probability of B given A. That's how you would literally read that. The probability of B given A. Meaning, given that event A has already occurred, what is the probability of B happening? We talked about this in terms of playing cards. The idea that, okay, well, what is the probability of this card being drawn given that these other cards have already been drawn beforehand? This is a conditional probability. There are conditions that have to happen beforehand. I don't know if you guys have ever made an agreement with conditions. The idea like, okay, your parents be like, I'll give you dessert if you clean your room. Okay, that's a condition. You will get the dessert given that you have cleaned your room. Event A has to occur first, and then you're finding the probability of event B happening after that fact. That's what that thing really comes down to. Now, we found the formula, or not found the formula, we wrote down the formula a different time, but I want to write down this one that I wrote down earlier so that we have it written into our notes. In order to calculate the conditional probability, it comes down to a fraction like this. You find the probability of A and B. You find the probability of both events happening, which typically is somewhere within the confines of the problem. And then you divide by the probability of A. Sometimes you have to do it that way. Sometimes you don't. It really depends on the situation. It depends. It really depends. Now, I'll give you kind of a silly-ish example. An example that maybe we don't even need this formula for, but then obviously we already just... Actually, no, I'll do the example with the ham and turkey first. We did this one. I want to make sure that we have it written down into our notes. The probability of ham given turkey. I want to make sure I have it in my notes as well. The probability of a family eating ham, given that they already have turkey. Assume they have a turkey. You walked into their house. You can see the turkey. Oh, cool. They have a turkey. Given that they have a turkey, what are the chances that they also have a ham somewhere hidden in the kitchen? No. It's like 27% according to this problem. Because the probability that they have both is 16. And the probability of turkey, which is the probability of A, is 58. And this gives you 0.276. I mean, the thing is, like, for example, if you already have a turkey, given that you already have a turkey, wouldn't you assume that there is less of a chance that you also have a ham? Yeah. I mean, if you're a big family, maybe you got both. Cool. But most families either only have one or the other. I know that my wife grew up in a family where they ate turkey at Thanksgiving and they ate ham at Christmas. A lot of people do that. And I'm like, dude, I don't like ham. Yeah. What's that? Fish? Really? Nice. What kind of fish? Okay. Is that a family tradition? Nice. Yeah, but I'm sorry. I just don't like ham. Fight me. Yes. Don't like ham. I like bacon.
Do you like turkey bacon?
No. Oh, no, it's pork roll. Come on. Are you kidding me? Come on. You're from the Jersey Shore. It's pork roll. Whatever. Good. Yes. Good question. No, actually, that was the point that I was about to bring up. That was a point that I wanted to bring up. Okay. Listen very carefully. Watch this. Last class, or not last class, I don't know which class I actually gave it, but I gave you this probability. The probability of A and B is equal to the probability of A times the probability of B. Now, that was if A and B are independent. If they are independent events. You know what I'm saying? Now, the probability of turkey, I'm going to bring my calculator up real quick right here. The probability of turkey is 0.58 times the probability of ham, which is 0.44. Now, that should theoretically give us the probability of turkey and ham, as you're saying, right? But it gives us 25% when the paper said, what did the paper say? 16, right? Well, keep in mind that this calculation only takes place if the two events are independent of each other. If they're independent of each other. meaning one does not depend on the other. Now, I can totally argue, based on this calculation that we just did, and based on what we just did under this paper, which I'm going to show you in a moment, I can show you that the two events are not independent of each other. They're not. Think about it. Like if you have a turkey at a holiday meal, mind you, holiday meal, okay? Not just a random turkey, but if you have a turkey at a holiday meal, you might have a ham. There's a good chance you might have a ham. And vice versa. If you have a ham at a holiday meal, you might actually have a turkey. It's just traditional. Well, traditional. Not everybody does it. But specifically because it's a holiday meal.
Turkey?
I do prefer turkey.
Yeah.
Yeah.
I like it.
So this actually leads me to my next point. If, I love if-then statements, if the probability of B is approximately, oh no, my papers, is approximately equal to the probability of B given A. If those two events in question are approximately equal to each other, then the events A and B are independent of each other. Now that actually is a very big deal here. And I'm very glad, I was going to point this out, but you noticed it before I brought it out. Now the probability of ham, let's say, the probability of ham, we know to be 44%. The probability of ham given turkey, we just calculated to be 0.276. Are those two percentages approximately equal? It's a yes or no question at that point. Are these two numbers approximately equal to each other? No, they're not. They're totally not. One's 44%, one's 27%. If it was like 44 and 43, maybe I could say yes. If it was like 44 and 41, I could still probably make the argument yes. If it was 44 and like 35, no, I can't. It's 44 and 27. It's 44 and 27. Conclusion. Having ham and turkey are not independent events. They are not independent events. Oh, the glare. I apologize for the glare. She's on the live stream. She's trying to read it. I'll read it again. It's all good. So where's the... okay, yeah. Okay. I moved the glare to that open spot in the middle. Now, can you say that they are dependent events? I don't know. I mean, you might not have enough evidence, though. See, the thing is, according to this definition that I gave you, the best you can say is they are independent or they're not independent. But you can't just flat out say they're dependent on each other. It's not that one immediately follows the other. What's that? Well, that's true. You can say one or the other, but you can't say that one follows the other. You can't just say like, oh, one depends on the other. You'd have ham if you had turkey. Not necessarily. The best you can say is that they're just not independent of each other during holiday meals. It's a weird kind of classification. But that's what you were asking for, like by, hey, what if I multiply these two together? They don't equal the 0.276. Yeah, they don't. They don't. And here's the justification behind it. It's so weird. Okay. Now, I am going to go a bit deeper on conditional probability when the time is appropriate. I am going to go deeper on conditional probability, but just to wrap up today, give me 1 second. Hold on. Who's in trouble? Marcus room. You're looking for Mackie. Yep. Bye.
Unreal.
Happens every day. Not every day.
Unreal.
I know. And see what's here's the funny thing. Mr. Mackey is Mr. James Mackey. And I am Mr. James Markey. And he is an A205, and I am in C205. Gotta be kidding me.
Did it get any worse? Or?
Last year I kept track of how many times I got missed call or incorrect calls. Huh? You never seen Mr. Mackey? He's the ROTC guy. Yeah. So this, I'm going to wrap up with this. This is on your worksheet, this little table of the foreign language that you take and the science that you take in a given semester, whatever the heck it is. I don't know. So right off the bat, given that they have all of this information, can you tell me the fraction of people who take chemistry? Just a flat out question like that. Can you tell me the fraction of people who take chemistry? Out of 136, yeah. The probability of someone taking chemistry, let's say, is 51 out of 136. Cool, yeah, okay. Now, check this out, check this out, check this out. What about the probability of someone taking chemistry given that they take French? Now hold on, think about don't answer just yet. I want to repeat some statements and to make some clarifications about this. This is a different probability now. Yes, there are 51 people taking chemistry out of 136 total students. Yes, you can see that based on this table, which whatever that decimal is, I'm actually just going to put this decimal up real quick. 51 out of 136 is 0.375. But now, given that they take French, given that the person is enrolled in a French class, what is the probability that they take chemistry? Not out of 51, not 136, out of 34. Given that they take French, when I say the phrase, think of it this way. When I say the phrase given French, I am actually saying, okay, given that you are only looking at French students, given that you are limiting yourself to only looking at the students who take French. How many students take French? So you're only looking at those. Given that you are looking at those French students, the probability that someone is taking chemistry, 16 out of 34, which is what, 0.471. This whole idea of given probability, that's what this thing really comes down to. It's really nice. So nice. I could also say like given Spanish. Actually, you know what? I'm just going to do that anyway. The probability of someone taking chem given Spanish is what out of what? Given that they're in a Spanish class, given that they are enrolled in Spanish. 35 out of 102. Which is 0.343. Now, what's really nice is, based on these numbers that are up here, I'm going to talk about this more next time, but based on these numbers that are up here, I can say that the type of science you take and the type of language that you take, they're independent of each other. Or they're, yeah. Or I'm sorry, not that they're independent of each other, that they're not independent of each other. I'm going to talk about this more next time. It's been a long day. Anyway, woo, class going to end. Bell's going to ring. I've been up since 4, dude. Yeah. See you guys next time. Yeah, but why were you guys up at 4? Were you helping